Okay, hi everyone. Today we are going to discuss one problem in linked list. Okay, create a copy of immutable list. Okay, what is immutable list? Immutable list means it's a read only. Okay, right? So basically, immutable means you cannot add new elements, you cannot delete any elements, something like that. Okay, so the intention of this algorithm is to create a copy of the linked list. Okay. Okay, I'm opening Geeks for Geeks. Here is actually this is more complex problem than simple problem. So I will explain simple one initially. Then we will think about complex one. Okay. So let me also start whiteboarding here. Okay. So let me explain the basic problem here. Okay. Here is the input. Okay. I can't write anything here. It's not working. Huh? I don't know. Maybe something wrong with the pen.
Yeah, it could be working, sir.
Yeah, for me, I think there is a pen actually. That pen is not working. That's fine. So I will try to write with my mouse. So basically, we have a link. We have a linked list. Okay, right? Every linked list has two things, right? Data and the next address. Correct. So here is the one.
Yes,
Here
sir.
is one. Here is the one, and here is the last one. Let's say. So this is pointed to this one, right? So these link, all four elements are somewhere in the memory. Correct. So they are stored in the memory, isn't it? So we need to create a copy of this linked list. Okay, how to create a copy? So basically, this is some first element somewhere here, second element somewhere here, and third element somewhere here, and fourth element somewhere here. Right. So the actual address here is what it is. Here is the address of this second element. Right. So now here what we are
Yes, yes, sir.
storing in the next address is the address of the third element. Correct? Right?
Yes, sir.
So now what we need to do is we need, let's say we have data like okay, 3, 5, okay, 8 and 7. We have these elements. Let's say 3 is here, okay, and 5 is here, okay, and somewhere 8 is here, let's say, and then 7 is here. Something the linked list objects will be created somewhere in the memory, right? It's not contiguous memory. It is randomly distributed in the RAM. Okay. Now 3 connected to 5, right? 3 the next pointer of the next address of the node 3 gives the address of the 5, right? Similarly, address of the node 5 gives the address of the 8. So the let's go to the question now. Okay, what is the question? It says, okay, create a copy of immutable list. Create a copy. Okay, let me also look at the um, here you can also say clone, basically cloning of the linked list. Okay, let's look at the problem definition. Okay, so clone a linked list with a next and a random pointer. Here, if you look at this one, right, this linked list has two pointers. One is the next pointer, one connected to two, two connected to three. The black line is next pointers, right? Let's assume every node has a random pointer also there. Okay, this is a little bit more complex, but we will come to the simple one. Let's first discuss about the simple one. Okay, here is an as an example of linked list random pointer given size n, where each node has two links. Okay, so what we need to do is um, so the idea here is to clone. The task is to create clone of the linked list in order of n time. So what is meant by that is, so you have to go through the elements. You can see my whiteboard, right?
Yes, sir.
Okay. So what we need to do is we need to create a copy of the linked list. That means we need to create how many elements in the linked list we have?
Four.
Four. So we need to create another four elements Okay, and we need to connect them. So that means we need to copy the entire linked list. We need to copy the each elements. We need to copy, that means we need to create a new node. We should not modify the existing linked list. That is the main thing. The problem here is you should not modify any of the nodes or values or the address of the given linked list. You need to create a new linked list. So what you need to do is, and that to order of n. You don't want to, go through the input multiple times. So if you navigate from 3 to 7, that's just order of n, right? So first, initially, if you want to count it, you can count it and create that many nodes, and that will, like, second time you want to navigate again. So we need to avoid that. So what we need to do is, so either you can, yeah, order of n means you can navigate. Of course, you can navigate two times. It's not a problem. 2n is also n, but it's not like n square. Okay, don't go with an n square solution. So how to create the linked list? So what is meant by this here is, we need to create new nodes. A node with three. So we need to create one more node with value three, right? A node with five. We need to create one more value with five. We need to create a node with eight. We need to create a node with seven. And these nodes should create somewhere in the memory. Look at that. That is the main thing. So we don't want to touch or modify any of the existing nodes in the memory, right? So this is somehow should be created in the memory. That means our four nodes will be created. Okay, three somewhere here, five somewhere here, and let's say eight is here and seven is here. Now these three connected to five, right? This is the initial three I'm talking about. Let's get back to the green. So the next address of the 3 gives the 5, and 5 gives the 8, right? 8 gives the address of the 7, and sorry, yeah, 3 to 5, 5 to 8, and 7, no one, like 7 did not, reference anything. It's a 7 is the last element, right? And let's see if you have a head is the that head points to the, from your algorithm, head points to the node 3, isn't it? Right?
Yes, sir.
Now the question is, we need to create similar linked list. Similar linked list means similar number of nodes with the similar same values, but they have to be connected with the similar way. That means you need to create head 2. Okay, you need to create like head 2. This head 2 must be pointed to 3, and this 3 pointed to 5, and this 5 pointed to 8, and this 8 pointed to this 7. So this is what we need to do inside the memory. This is completely new nodes. Okay, how are you going to do that? That is the thing here. So what are the ideas to do? Because let's say,
Means
yeah, go ahead. Let's start discussion. Yeah.
we need to traverse and we need to assign that values to new linked list maybe, sir.
Yes. Okay. So you traverse the first linked list, and you touch each node and create the brand new node, right? And
Ah, yes, sir.
you create the brand new node. You copy the value. You copy the value, whatever the value here. You copy it, and next what you do is, you will go to the next node. Okay. You will create one more node, a new node, and copy the value. Correct. Okay.
Yes, sir.
So then you have to connect the old, like the brand new node what you created before, that has to be connected with this node, right? Isn't it?
I
So,
didn't get. Can you repeat
so
that one?
what we need to do is, you created five. You created five. Okay, it's by seeing the five here, you created a new node with five. But this five need to be connected from this three, right? The three need connected with this five.
Yes, sir.
Previous node, basically previous node. Okay. So again, if you go to from 5 to 8, you create the node 8, and 5 needs to be connected with this new 8, isn't it?
Yes, sir.
So that's how you need to do. So basically, you need to navigate through the elements and you create the nodes and find out which node to be connected to which node. Okay. So let's look at the different approaches here. So one is, okay, I think I opened the wrong one. Okay. Let's go to the, yeah, here. So how to do this, right? So there are multiple ways to do it using extra space. The idea is to solve the problem. So you can use extra space, and without using extra space also we can do. So follow the steps. So um, let's look at the simple algorithm that I made here. Okay, so that we can easily do this. Okay, so let's explain the simple. This is the node structure, right? Node and then next node. Okay, node and next is the next pointer. We don't have any random pointer at this point. Just go with the simple approach. Okay, so what I'm doing is I created three elements, one, two, three. Okay, now I'm printing the list. Now what I'm doing is clone mutable linked list. Okay, this is the function we are executing. What it does is without changing the original node, but you can use extra space. So we don't want to change the original node. We don't want to change the original list. Okay, so how can we do this, right? Yeah, so this is the algorithm. I will go through the algorithm, but before that, let's see if we can do with what are the different approaches. Okay, let's say if you take yeah, so how can we do this with by navigating the elements,
Each node.
right? Each node, basically by navigating each node. So I was like let's look at that. Let's say P1 and let's say take P2. Okay, now P1 first assign with head. Okay, if you go with the head, right, you go with the head. So you can have a while loop or loop while P1 becomes empty. Now what you need to do is you need to create for P1, you need to create, let's say, N1. That means you need to create N1 is the new node. Okay, and you need to copy the whatever the value 3 into that N1. Okay, now P2 is null. Since P2 is null, what you can do is P2 equal to N1, you can assign that, right? P2 equal to
Yes.
1. This is like a head for the second linked list, the new linked list. Okay, now you advance the P1 to the next node. That means now P1 pointed to 5. Okay. Now N1 becomes 5. You create a new node called a 5. Okay. Now what you need to do is you need to you need to connect P2. P2 is like P2 is a like let's say P2 and head 2. Head 2 is equal to N1. So what I'm saying is, so here is the header 2. Final header 2 is pointed to the 3. Now from this point onwards, you update only P2. That means P2 dot next equal to N1. Okay. P2 dot next equal to N1. What will happen is P2 is a pointer, right? Pointer is now connected to P2 connected to this one. Now P2 dot next equal to N1, which is new node, and P2 connected to P2 dot next. Basically, it connects to the next node. So basically, you are establishing this connection, right? You are establishing this connection. You got my point? So what I'm saying is, I assume we can, by having a two pointers, we can do it.
Yes, sir. Yes, sir.
Hmm? So
Yes.
let's see, so this is the one way of doing it. So by having this you never change head 2. Don't change the head 2 anytime. Head 2 is just always pointed to 3, the new element that you created in the memory. But P1 P2, okay, P1 is a pointer for the main list, and P2 is basically a pointer for the second list. Okay, so once your P2 is completed with 5, like P1 completed with 5, P1 you proceed to the next level, which is like 8. Okay. Now 8 you need to create new node, which is N1. You created a new node with 8. Now P1, of course, after you establish the connection, P1, P2, P2 equal to P2, P2 dot next equal to new node. You need to assign, right, P2 equal to N1. Now P2 is pointed to 5. Okay, it's kind of while loop. In the while loop, what you do is every time first step is create new node, which is N1. Okay, second step is connect P2 dot next. I can't write properly here, and is equal to N1, because P2 is basically the previous node, right? In this case, P2 is 5, right? You just created node 8, N1 is 8, N1 is 8, and then you connect P2 dot next equal to N1, which is like 5 connected to 8. And third step is simply overwriting P2 equal to, what is that? Can you tell me what is the next step? P2 equal to
N1.
and 1. Very good, very good. You're following so far. So now P1, P2 becomes 8. We're waiting for the next node to be connected. That is how it is. Right? So now what will happen is, again, you progress again, the while loop goes on to the top, and P1 becomes P1 equal to, of course, the last step here is P1 equal to P1 equal to P1 dot next. That way, P1 will go to the next step, which is 7. Now again, you create new node N1 with the same value 7, and you connect with the P2 connected to the new node, right? And again, P1 connected, you P2 becomes 7, right? P1 becomes null because P1 there is no next node for that, and finally you end up having a new linked list with these nodes, correct? So by using simple pointers, how many pointers we used? We used only 3 pointers: P1, P2, and head 2, right?
Yes, sir.
So this is one way of doing it. There is another way of doing it also there. So I'm trying to see what is any problems with this approach. Are we doing right, or are we missing anything? Because let me look at the other algorithms. They have other algorithms here. There
Sir,
are.
can we do it with recursion?
I don't think we can do with recursion, because how can we do with recursion? Yeah, maybe it's possible. No, no, it's not possible, because recursion. Um, Maybe we can do, but it's really not required. It's just a simple loop, right? Simple loop from first node to the last node, right?
Yes, sir.
So what is the work? If with recursion uses unnecessary stack here. Why do you need stack here? We don't need to use any stack, right? So recursion uses the stack data structure. So here, without any using any new data structure, you did not use any hash tables or arrays or anything. We used only 3 pointers. We used only 3 pointers to make this happen, right?
Yes, yes, sir.
So that's why we don't need to write any recursion. So now let's look at the different algorithms. So the problem here is, without any new another pointer like random pointer, we don't like random pointer is there, then it becomes so difficult. Because let me explain you the random pointer concept. What is random pointer is, let's say 3 connected to 5. Now 3 also connected to 8. There are 2 pointers basically. One, this is called next pointer, and this is another pointer called random r. This random pointer connects to some other node in the same linked list. Okay. Now eight random pointer connect to the 5. Just assume that. And 5 random pointer connect to the 7. And 7 random pointer connects to the 5. So this is a clumsy kind of random connections. There are two addresses for each node. Each node has three things. Each node has data, which is data D, and a next address called N, and a random address called R. The random address is connected to some other node in the linked list. In this situation, what will happen is, you can easily connect the next node by having these pointers. You can easily connect You can easily connect these. You can create the new linked list. But how about 3 connected to here? You need to connect this 3 to the 8, right? So the 3 need to connect to the 8, correct? So in the new linked list also, you need to connect those random pointers, correct?
Yes, sir.
So that becomes really complicated by using this just pointers, because you can create 8 and you connect 5 to 8, but you don't have the p1 already p2 updated to the 5. You don't have connection to the um, 3 anymore. Similarly, when you go to the 8, P2 pointed to 8, right? But you don't have 5. 5 needs to connect to 7. So you don't have 8, you can connect to 7, because you can have P2, you created N1 with 7, and you connect 8 to 7. But how can you connect 5 to the 7? Because you lost that point. You have only simple pointer that you are keep moving with a single pointer, or if you have only next pointer, you can easily do with the pointers. You no need to maintain any data structure or any additional data structure. But if you have these random connections also there, then we need to have a different approach. Okay, that's what they are explaining here. So one is using extra space. The idea is to solve the problem. So what they are doing is we have to use a map. Okay, so we can use a map, basically hash table. Okay, so look at this. So creating a copy of nodes and the next pointers. So we can create a copy here, and then in the next time they will create the new pointers. Okay, so I will explain in detail. Okay, so there is one more concept. That's first one is using a data structure, using a map, using a hash table. Okay, using table is one approach, hash table or a map. Okay, so next approach is, let's look at the second approach. Approach 2, using constant extra space. The idea is to solve using the extra constant extra space. Okay, create a duplicate node and insert in between the nodes, and then okay, this is more complex approach than the first one. So it's not basically using the using the entire, let's say you have 1,000 elements. So now you're creating a dictionary or map with 1,000 elements, right? So instead of doing that, so they are not creating 1,000 elements. Okay, so this is like modifying the existing linked list. Okay, so this is a little complex, I would say. Yeah. Let's go with the first approach. And there is another, recursion. You are right. See, third approach also there, which uses the recursion, so which could be another complex approach. So let's go with the map approach. I'm going to explain the map approach. Okay, the first one, which will be the easy one to understand. Okay, so the idea here is, let me draw the elements again. Okay, let's say 3, 5, 7, and 8. Right? Okay. So we have this simple connection. Let's don't complicate ourselves. We just have a simple next pointers. Okay. We want to create new set of nodes, isn't it? Okay. Um, okay. So what we are going to do is, we will create. Okay. We will create new nodes. We will create new nodes. Okay. We'll create 3. Okay, and we will create 5, but we don't connect yet. So okay, first what we will do is, along with create, we will go through the first linked list. You will go through the first linked list and create new nodes. Okay, create a node for each of the node, and we will also maintain a hash table. That is what key value pairs. Okay, what it does is, what is the key and what is the value. Okay, the key is basically the node of the original linked list. That means if you find if you find, let me use the blue. If you find a node with 3, okay, use a new node with 3. That means basically you will map this address with this address. Okay, what I'm saying is, let's say this one is 1115, this is the address of this node. This one is 2225. Okay, so if you want the duplicate of one, duplicate of 3, if you want the duplicate of 3, duplicate means we are creating a new node, right? If you want the new node of 3, okay, you just go to the hash table and look for this key 1115. So 1115 will be here, 1115 map to the 2225. That means this is the address of the duplicate of this node. You got it, Sunil? Basically we are mapping
Yes, sir.
this address to this address. Okay, so what will happen now is, so this is the if for any node, so let's say this one is 1116. Just for the easy for the easy example, I'm just giving the same numbers, 111. This one is 1117 or 1117, so it will, this will be in 2227. So 1117 map to the 2227. So that means whenever you want the duplicate node of 5, okay, go to the hash table and get the address that will give you the duplicate of this node. This is the duplicate of this node, this is the duplicate of this node. That is the arrows they are representing in the diagram. So basically you are it's not like we are pointing these no nodes. It's not like an linked list pointer. This is not a linked list pointer. This is, all these arrows are key value pairs in the hash table. You got it? So we will create these new nodes and we will put it in the hash table. That is the first thing. We are not connected these nodes yet. Okay, you got my point? So
Yes, sir. We-
yeah, so what we do is, now we need to connect these nodes. Now we created all 4 nodes. Now we need to connect these nodes. Okay, what we will do is, let's see, I think am I correct? The approach is, I think, let me look at the code I wrote. Is it new node to the old node, or yeah, p dot next equal to hp? Let me look at the way we are doing it. So here is the dictionary. We created node dictionary. Okay, and t equal to head. This is what I'm talking about. So while loop, t equal to head. Okay, what we are doing is basically cloning, right? Let's look at the algorithm. Head equal to null, return null. If the head is null, you don't need to copy anything. Otherwise, what we do is we'll create the header too, and we also creating a dictionary. This is the dictionary I'm talking about, right? So node and node. So new node, this is the old node and new node. Let's see which one is the key and value. So now t equal to head. I started a pointer called t, started with head. While t not equal to null. Basically, t is a pointer that will navigate each and every node. Okay. What are we doing? We are creating a new node. And look at this. As I said, old node is the key and new node is the value. You got my point here? We are adding into the dictionary. We are adding into the dictionary just like I showed here. Key is the old node, key is the old node, and value is the new node, address of the new node. Got it?
mm, Can you show once code, sir?
So you want me to show the code?
Yes, sir.
So here is the thing, sir, right? So you created a new node with the data. Your T is basically pointer to the original node. T is the original node, and you're creating a new node called N with the value of the T. Let's say you got the node 3. 3, a new node with
Uh,
value 3 will be created.
yes, sir. I got it, sir.
Now you're adding both the nodes to the hash table. Okay. Now head to not equal to null. This is the condition. Like if the head to is null, that means you haven't created any. This is the first node you created. Simply you tag that. Oh, this is the new head. We want to return that head to, right? So this is the only condition that will save the address of the new node, address of the first node in the second linked list. Now what are we doing? Simply t equal to, okay, t equal to t dot next. We'll go to the next one. So after all this entire while loop, what will happen? This exactly happened like I showed in the whiteboard here. It will create the new nodes. It won't connect any new nodes yet, right? It will create the new nodes with the 3, 5, 7, and 8. It will create a duplicates of the original nodes. Along with that, we are also creating a hash table, correct?
Yes, sir.
Now what are we doing? Let's look at this algorithm next. Next one is t equal to head 2. So again, now t is a pointer that will points to the head 2. Now t equal to head 2. This is head 2, right? Head 2 is pointed to the number 3. Now t equal to head 2. Now t equal to 3. Now we need to get to the 5. So we need to connect this 3 to this 5, right? How can we do that? How can we do it is, we also need to take p equal to head. We are taking two pointers, okay? So let me show you the next one. So what are we doing here is p, p equal to head, p pointed to 3, okay? So now we need to connect 3, okay, 3 to this 5, this new node 5. How to get the address of this 5? Okay, basically p dot next, p dot next is this 5, right? The top 5. So if I say p dot next, which is 5, and if I ask, hey, what is the duplicate, what is the address of the p dot next, that will be available here, 1117 equal to 2227, right? So that is the main logic here. T dot next equal to, that means t dot next equal to p dot next, h of p dot next. What is the basically h? This is a hash table. H of p dot next. What is p dot next? 5. So 5 address is 1117. That will give you the 2227. So it will connect it to the 2227 node. You got the point? So let me show you the code to understand. So what I'm saying is, okay, if p dot next not equal to null, that means there is a next element. There is an element after p. P is the first element of the original list, right? So if there is an element after p, if there is an element after p, what we are doing is t dot next equal to h of p dot next. This is a very crucial thing that we need to understand. You got the point here, Sunil?
No, sir.
No, let me explain again. So p, what is the p? P is 3, right? P is
Yes, sir.
3, P is 3, and T is this 3, a new node with 3. So P pointed to the old node of 3, T pointed to the new node of the 3, right? Our
Yes,
intention is to connect this new node with the new node of 5, isn't it? We don't know the address of this node. How do you know the address of this node? How to connect these two nodes? The 2227 can be retrieved from the hash table if you know the original node 5. If you know the 5, you can get the duplicate for 5. If you know the 7, you can get the duplicate of 7. You got that point, right? Hash table gives that value. If you know the address of the original node, you can get the address of the duplicate node. Correct? You understand?
yes, sir.
You understand how hash table was built, right?
Yes, sir.
Now we need to get the address of this one 2227. We want to get the address of this new node 5. How to get the address of the new node 5? By looking at the hash table, by supplying the key 5, by supplying the original node 5, by supplying the original node 5 into the hash table, which is like 1117 here, that will give you the 2227, right? So what I am trying to do is, if p is 3, p is equal to 3, p dot next equal to not equal to null. P is not a last node. Okay, p is not a last node. Okay, now that means p dot next is some value is there. That is the condition. First condition here. Look at this. P dot next not equal to null. That means p has a next node. There is some node after p. Right? You understood this point, right? If condition. Right? Now what are we trying to do is
Yes, sir.
look at the hash table. Give me the duplicate of that new node. We don't want this node. We want duplicate of this 5. Duplicate of this 5 means whatever the new node you created using this node. Using this node 1117, we create a new node. The address of the new node is 2227. So that is what we are trying to do here. Hash table of hash table of we are supplying the next node of the original linker list. Next node of the original linker list. This is the next node, right? That means we are supplying this
Yes,
1117. Then what we will get? We'll get the address of the 2227, right? That we need to connect to the t, right? T dot next equal to that value. Now this new 3 is connected to the new 5. See, t dot next equal to, look at the hash table, and hash table of old node 5. That will give you the new node 5. You got this point now?
yes, sir.
This is very crucial. This is the only step that will help you to solve the other problem, because the random pointer also can be solved like exactly the same way. You can put another if condition. Basically, let's say this p has a next pointer. P also has a random pointer. P also has a random pointer that connects to the 8. Let's say the random pointer, there are two pointers, right? So the random pointer connects to the 8. Now, this 3 also need to connect to this 8. How can we do that? Simply, if the random pointer is null, simply t dot random equal to t dot r equal to, look at the hash table. Can you tell me what we need to put here? P dot rand, right? You got my point here? P dot rand means 8. So here is h of
Yes,
8. H of 8, hash table of 8. This will give you the duplicate of 8. That's what we are going to connect with the t dot random. So now we are establishing this connection. You got the point, Sunil? I know
yes, sir. Yes, sir.
I know it is confusing, but it will definitely help you. So basically, if you try to understand that single point here, why are we doing this? So we went with this hash table approach because to solve that random pointer problem. So that could be your internal like interview question. It's not like, hey, create a copy of the normal linked list is nothing. You don't need to create any. You don't need to use any hash table or anything, right? Because we already solved with 3 pointers previously, but we are using hash table in order to map old nodes to the new nodes, right? This every old node, if you go to the hash table, tell me what is the duplicate of 8, you will get the duplicate of 8. Tell me what is the duplicate of 7, it will give you the duplicate of 7. So this hash table is very handy for you. You got the point, right?
Yes, sir.
So that is what the main intention of this algorithm. This is like crucial step in the algorithm. So what we do is you connect it. Okay. Now what we are going to do? Let's say if there is okay. So if let's say this condition is null, this condition is false. What is meant by that is p dot next equal to p dot next not equal to null or becomes null. P dot next becomes null. What is meant by that? P dot next becomes null means p becomes the last
It
element.
is.
P becomes the last element. So let's say if p you completed p with 3, 5, 7, and 8. Now p is the last element 8, and p dot next is null. If p dot next is null, you also need to say now t is here. T is here, right? T dot next equal to null. So now let me see. T dot next. Okay, T dot next equal to p. Yeah, T dot next equal to null. So now t becomes the last element. So you no need to point anything to the to this element. Okay. So now let's look at this one. P equal to p dot next and t equal to t dot next. You simply navigate to the next element. So now basically, if this is not the case, you're done with 3. Now p becomes 5 and t becomes 5 because you just created this connection. You just created this connection and you are navigating using that connection, right? So you just updated here, right? So t dot next equal to new 5. So now t becomes 5. You got the point, right? So now again you go to the top and then you get the next pointer of 5. So what is the next pointer of 5? 7. Okay, you go to the 7, and what is the duplicate of 7? Then 5 will be connected to this 7. Now t becomes 7. Okay, and p becomes 7. Okay, and p dot next, what is the next point? So 8 connected to this 8, the duplicate of 8, right? And then p becomes the 8 and p becomes 8. So both will be set to the null because p dot next equal to null. We'll also set the t dot next equal to null. So finally we will return head 2. Head 2 is the pointer to the new linked list. Okay, you got the whole understanding of this algorithm.
Yes, sir. Yes, sir. Sir, can you show me how to add means that nodes to hash table, sir?
Nodes to the hash table. That's a good point. So we are doing here. So here is a hash table is basically dictionary in the C sharp. It is called dictionary. In the dictionary, we are taking the types node and node, which is a h here. Now h dot add equal to old node. T points to the old node, right? T equal to head, and we are creating a new node equal to n. So for every old node, here is a new node. For a number 3, here is a node with number 3. A node with number 5, here
But
is node with number 5, right?
yes, sir. But here we are not adding means address not right, sir. We are adding data right, sir.
We are not
Node
adding
n equal
data.
to new.
We are not adding, I'm not adding t dot data. I'm adding a t, directly adding this node t.
Okay, okay, sir.
Look at that. It's not like I'm not adding like t dot data equal to n dot data. If you add data, it is really tough to connect the nodes, right? If you add data here, whatever the, let's say, is employee names. If you're adding employee names, how can you connect the nodes? We need the addresses. That's why I put here 1115, refers to 2225. 1117 refers to the 2227. The reason I referred like this is we are storing the address. We are storing the direct T, entire T object. It is very it is very memory consumption. Unnecessarily you are storing, of course it's an address only, but if you have million elements, you are taking a hash table of million elements, right? You're creating a hash table. This hash table will be created inside a memory, right? So all these nodes are in memory, million nodes. You are creating another million nodes in the memory. You also creating a big hash table of million nodes, which will map from old node to the new node, right? The solution is simple. The solution could be simple, but it is using a lot of extra space. You got the point?
Yes,
Okay.
sir.
Yeah. But that is a straightforward solution. In the interview, if you even if you explain the solution, I will be super happy. I don't even expect people to write this much complex code. This is complex code. It's not easy, right? So remembering every step here, adding this step here, and also referring this step here, there could be a lot of chance you will write logic which may not run, or there could be a lot of bugs. But what I expect is, in this algorithm from the candidate is, they should be able to explain this algorithm, at least explain the algorithm. Hey, I will take a hash table, I will map old node to the new node, and I will first iteration I will go through the entire list, I will create this hash table. Second iteration I will go through the new nodes, and using hash table I find the new node and next address of the new node. I will use the hash table as a mechanism to map old nodes to the new node. If you explain the whole thing, I will be super satisfied. I don't look for your code, because you know what to do, right? You may not be able to code in next 20 minutes, but if I give you 1 day or 2 day, you should be able to crack the code. I will get that confidence, right? So this kind of algorithms is all about uh, giving confidence or establishing confidence with the interviewer. I don't expect a developer to write 100% great code with this kind of algorithms. This is all explanation. So now, like, if this is the interview question, you go with the pointer approach, and you can explain pointer approach also. But if I give you the random, right, this random pointer, then the pointer approach will not work. Pointer approach, then what you can see is, like, if I really want to ask this question with this random pointer, I don't ask this question directly. I will always ask simple question. Hey, how to clone the simple linked list which has only next addresses, right? If you as a candidate, if you say using 3 pointers, I will be super happy. Okay, you are come up with a great algorithm which doesn't require any additional data structure, right? If you said, hey, we can create with, we don't need any hash tables or trees or stacks or anything, we can simply maintain, we can create a new linked list using just 3 variables, correct? Now if you answer that question, then I will extend the question. Hey Sunil, great answer. Now let's consider a linked list with two things. One is next pointer, another one is a random pointer. I will extend the question to the next level. Then you should say, hey, 3 pointer approach may not work. You should explain why it may not work, because you can't track of these random pointers. You cannot go directly from 1 to 3, 3 to 5, right? So 3 connect 3 dot next you can go. So let's say 5 connected to 2 here. So how can you go from 5 to 2, right? You may not be able to maintain that many pointers, right? You can have only 4 connected to 5. You can simply connect the duplicate of 4 to duplicate of 5. But where is the pointer? Where is the pointer for a number 2? You cannot connect. Or where is the pointer that connects to 3? So you cannot connect 4 to 3. You cannot connect 5 to 2 using pointer approach. That's why then you should say, hey, it's not possible with pointer approach. We can do this using hash table. Then I will discuss, hey, very good Sunil, let's talk about how are you going to solve with the hash table. Now if you explain this whole procedure, I will be super satisfied. I don't look for any algorithm from you, because you crack the code, you understand the problem with the pointer approach, you understand with this approach. So this is all discussion related question, I would say. Okay, so that's how you should tackle the interviews. Is it clear, Sunil?
Yes, sir.
Yeah. Any questions on this one, or I can share the algorithm if you are super clear on this one. Okay. So this in this algorithm, I created only the
Okay.
normal one. I did not use random pointer approach. Maybe we can extend this algorithm to random as well. So for the time being, I will run this code and show you. So what you can do is you can modify this algorithm if you have some time today or tomorrow, or try to add one more variable here, right? One more variable called rand. This is the next variable, right? So you can create one more thing, rand, and then store the rand as well, right? So in addition to, basically
Okay.
what you need to do is, what you need to do this is a value v1, right? You can say v2, or you can store a tuple here. You know the tuple, right? Do you know the tuple?
Yes, sir.
So tuple means two values. For every key for 1115, you are going to add a next node and random node. So you can have that kind of, the basically value v1 v2. So if I say 1115, you will get both the values. You if you go to the tuple, you take this tuple, and first one will give you the 3 connected to 5, and the second value will say that 3 connected to 8. So you will give the value. So that way I think we don't need, actually we don't need to use tuple. Wait, I think I'm giving wrong impression, because you just need the duplicate of these values. You just need duplicate of 3, duplicate of 5, duplicate of, so similarly you can say that, yeah, I just showed here. So t dot next equal to h of p dot next, and t dot rand equal to h of p dot rand. So you can get the duplicate of 5 by going with p dot next. You can get the duplicate of 8 by going with p dot rand, right? So this only I think key value pairs is enough. Only one address is fine. So basically this is basically the duplicate of new node, right? So for 3, this is the new 3. For 5, this is a new 5. So that way you can easily find this one. So it is a matter of changing. I think what you need to do is, you no need to modify this function, this first one. You no need to modify this adding the link, adding the dictionary. What you all need to modify here is just another if condition. That's it, actually. So if I simply say, you can modify with like this. Oh, I think I need to sign up. I need to sign up in order to modify. So just another condition for random. That's it. That's it. You got my point, right? So you just need to write similar if condition for rand pointer. That's it. Then it will take care of random. You got the point?
We need to make it
What is that?
unvariable, sir. P dot. Mm, we need to make in both condition is true, then only we can go go into the if condition, and then only we assign that value, right, sir?
Yes, yes. So like, yeah, we will create another condition if p dot rand not equal to null. Let's say some of the nodes, they don't have any random value, random node. Then you don't need to map anything, right? So I'm trying to log in here. If I log in, I should be able to edit this code, actually. So that's why I'm trying to log in. So you are right.
Yes.
So we need to check for the rand condition. If the rand is not null, that means, let's say 3 connected to number 8. That means rand 3 dot rand equal to 8. So then you look what is the duplicate of 8, right?
Mm,
Okay, I'm trying to log in here. It's taking a little bit long. Okay, come on. It's still navigating. Looks like, yeah. But you understood, I think, I hope you understood the whole algorithm, I think, right? So basically, you need to add this condition for the
sir.
random. Okay. If it logs in, I will be
Okay,
able
sir.
to modify. Yeah. But anyway, so it's a kind of exercise for you. Try to I think you can easily look at this algorithm, and the Geek for Geeks also gave the exact same solution. Okay, now it is redirecting, but in the meantime we can see this one. See, they at first node, they created this, created the duplicate nodes, and then at the second node, like look at this, they are creating that random nodes. See, one connected, two connected to one here, two connected to this one. Okay, so so this is exactly the same procedure what I just showed. Okay, so you can go to any C, C++, Java, Python, you can see that code, you can understand that. Okay. Okay, that's cool. I think, yeah, I think that's it pretty much for today. I will send this code. Okay, I will send the a link to this code, and you can go through the code. Okay.
Okay, sir.
So let me send right away. So I think it's taking time. So next week probably we will look into the double link list, or we can start the trees. If people are there, it will be nice if more people are there. So that, okay. So I'm going to send here
Yes, sir.
the record.
Yes, sir.
Okay, it's taking really long. Okay, let me. Okay, here is the. Okay, I will send the link. Somehow it is copying as a URL. So I will change that into normal URL, and I will send it here. So let me also stop recording. Okay.